4.5, number 222. It's very similar to the previous problem, but there's a little nuance here with the particular function they've chosen. So f of x is now x squared plus cos x. The same two types of questions: find where the function is increasing or decreasing, and find the relative extreme locations. All right, so we need to do the same thing. I'm going to take f prime, the exact same moves we did before. So we'll get 2x minus sine x. And we'll know where this is equal to 0 or undefined. Again, since it's just a polynomial and a trig function subtracted off, we don't actually have to worry about where it's undefined. There is no place where it's undefined. So we're really just focusing on the equals to 0 again. The problem here is you have x trapped inside a trigonometric function, and you have x outside of that trigonometric function with this polynomial. So therefore, you will not be able to solve for x in the usual type of way. So what they're anticipating here is one of a couple of things. One is you'll recognize that a solution to this equation is x equals 0 by inspection. Okay. Now, there's two ways to realize that from inspection. One is, certainly if you just plug 0 in, 2 times 0 is 0, sine of 0 is 0, 0 minus 0 is 0. Knowing a lot about zeros and lines and trig functions, it's not hard to tell that 0 will solve this. There's another way to understand it though. This is an even function back here. The original function was even, and therefore its derivative will be odd. So this is an odd function. Or you can understand this by f of x is odd, and therefore it must go through the origin. As long as x equals 0 is in the domain of an odd function, it'll be forced to go through the origin there. Therefore 0, 0 is a point on f of x. That's another way to look at it. That's not as obvious. But anyway, so x equals 0 is our critical value. So either way, critical value of x equals 0. Now, there's something a little more difficult here, and that is, well, how do I know that's the only critical value? Maybe there's another one and I just can't solve for it because the problem is too difficult. So this is a good way of thinking. The way to tell this is, and I don't know if the book expects you to do this at this point. I'm kind of surprised this problem is as subtle as it is. But what you could do is take the next derivative, take the second derivative. Okay? So f double prime is 2 minus cos. All right. If we look at this, what we can notice here is that the cos function is trapped between -1 and 1. Right? Trapped between -1 and 1. So therefore, 2 minus the cos function, you can say, is always positive. Right? Well, if this function, 2 minus cos x, is always positive, remember that's the second derivative. So what would that mean for the first derivative? Right? Again, the second derivative is the first derivative of the first derivative. So if the second derivative is always positive, right, that implies that f prime, the first derivative, is always increasing. It's an increasing function. Again, it's a little subtle, but it's good to think about. It's an increasing function. Well, if the first derivative is an increasing function, it's always going up, then once it goes through a value of 0, right, it goes through a height of 0, it goes through its root, we just found, right, the 0, 0 location. Once it goes through there, it can't come back down to get through another root again. It can't intersect the x-axis again because it's always increasing, always going up higher. Okay? So therefore, this is how we know 0, 0 is the only root of f prime. We found one root that it has, and we can tell from the second derivative, because the second derivative is always positive, the first derivative is always increasing, and therefore this is the only root that f prime has. So therefore 0 is the only critical value. Is the only critical value of the original function of f of x. All right? So that's what we have to work with.